Greetings, everyone. Welcome to another session of the Ecosystem Restoration Camps Foundation online course. This will be the second session for the course that I will be running. We're talking about restoring arid land with permaculture, an example from Jordan. So we'll be discussing the strategies and techniques used for restoring land in Jordan. And I think more specifically, we have to mention that in this particular instance, this is an application to where we're actually applying permaculture to the farm design. We're actually designing two agricultural plots, two research and development agricultural plots in the Jordan Valley / Dead Sea Valley. And this is very important to be clear about because this is something that has to be performed or carried out in a way that allows for marginal farmers, in this case, your average marginal poor farmer in Jordan, to actually be able to make a living while also utilizing these techniques in a way that hopefully improves land in the process of producing food rather than degrade it. So a lot of what's being discussed here really is based in understanding how the hydrological cycle works, because what degraded land ultimately results in is a disruption of the water cycle. And once you have degraded land on a large enough scale, you actually begin to see changes in the way that weather behaves, and most notably in the patterns of precipitation, which is especially critical in an arid climate setting like that of Jordan. So typically what we see, if we were to look at this graphically, and this sort of describes what is seen historically speaking with the decline in the quality of land, the degradation of land over time. Usually what happens is you have the removal of vegetation in a given landscape. That removal of vegetation, since the ground is exposed, will result in a disruption in the quality of soil and the ability of soil to be built, because the vegetation is the primary means or source of organic matter to degrade biologically, ideally, and then eventually build those soils so that you actually can have continued fertility and nutrient cycling, and also most importantly, or just as importantly, the retention of water. And then once the soil is disrupted, you begin to see this broad systemic breakdown, which not only is manifested in the disruption of the terrestrial dynamics, but you also begin to see this impact the atmospheric dynamics. And you can see this reflected here in the figure. You can see this highlighting of albedo. Right now, albedo is just the reflective or absorptive behavior of a surface. And one of the reasons why albedo is a problem is all of the light that enters into the atmosphere from the sun, instead of being absorbed by the surfaces, the relatively dark surfaces of plants, this ends up being reflected back out into the atmosphere from the light-colored exposed ground. And this certainly was the case if you remember the video that was shown in the last session. You can see the light-colored ground and how the sunlight would reflect off that ground and go back out into the atmosphere. Couple that with the tendency for that light to also have its heat stored in the atmosphere, right? The water vapor that's in the atmosphere, the dusts, and all those things, and then you can see how you would have again a warming atmosphere. Now, if we take a look at how, again, water interacts with a given landscape, ideally you have water falling. You have a certain percentage of that water actually being infiltrated into the ground if the soil is actually open and receptive to receiving that water. And then depending on how much organic matter is in the ground, it would have a certain percentage of that water also be absorbed and stored. Then you have, a portion of the water that would evaporate back out into the atmosphere, certainly if you have ground that's very exposed. You have a percentage of the water that actually is transpired back out into the atmosphere through the surfaces of plants, and then a percentage of that, another portion of that water that actually runs off. Now, the problem is which one of those ways for water to enter and leave a given landscape, which one dominates? So if you have more evaporation and more water running off, then you have water actually being infiltrated into the ground and then transpired through the surfaces of plants over an extended period of time back into the atmosphere. If water is leaving much faster than it's able to enter and stay and be used, then we have a problem. And this is certainly something that we see in the case of the examples from Jordan, is that we have a couple of farm plots that are pretty well degraded, not necessarily as bad as some other areas in the region, but they're not in great shape. And then you certainly couple that with the other factors associated with soil in terms of the pH content, salt content, and the actual structure. So in particular, when referring to structural problems with soil, we're talking about things like compaction, most notably. So the compacted condition prevents air and water from getting into the deeper layers of soil that would allow for whatever plants that are trying to establish to receive what it needs or what they need in order to survive. So one of the first things that needs to be done is to actually address this compaction condition so that we can actually get more efficient use of whatever available air and water there is. So we can see how compacted soil actually creates a problem for plants, for instance. And you can see this actually reflected in the stunted growth of a lot of the ground cover. You'll see often very patchy growth. Again, not very good growth from the grasses, and you'll also see this reflected in, especially if you have water falling, that you don't get very good infiltration of that water. It'll tend to sit on the surface, and if it sits on the surface to where it's exposed to the sun and the wind, then again, this will cause the water to evaporate. And then oftentimes what happens is it leaves the salts behind, which if you get enough of that water evaporating and enough of that salt to settle on the surface, it becomes actually quite a toxic environment for any vegetation to be able to survive, except for the most sort of drought and salt tolerant species. But certainly many of the productive species, the crops that would be preferred by farmers, they're going to find it very difficult for those things to be able to survive without quite a lot of help. So in moving forward, the real key here is to create an arrangement which, as we had noted at the end of the last session, we need to create an arrangement that minimizes evaporation, right, by way of the sun and the wind. And this is done by creating shade, mulch, and windbreak. And then it maximizes the retention of water. And this is done by increasing the amount of soil organic matter in soil and the nutrient content of soils, and then also increasing the biological activity and content of soils, which would actually help us to get better nutrient cycling and then better growth, better yields, and better function. So how do we do that? So in the case of how we've proposed to create an arrangement on the farm which affects all of these outcomes, we're looking at a much more diverse, multifaceted, and multi-layered arrangement of the plants and the different species that are within these landscapes or on these farms. So really what we're modeling is what has historically or traditionally been used in many areas in this part of the world, which are basically agricultural oases, what in kind of modern parlance is called a food forest. But in this instance, what we're doing is we're just taking species that are suited for this climate, and we are creating an arrangement where everything is basically put together. It's sort of like you're putting the pieces of a puzzle together. And so we have all of these different layers. We have overstory trees, which are sometimes called climax species. We have understory trees, nitrogen fixers. We have ground cover, maybe small bushes and shrubs. We have climbers and vines, the herbs. We have all of the different layers that are actually pieced together because they're all occupying a spatial and a functional niche that's necessary in order to produce the outcome that we're going for. So in the end, what that does is it creates this multifaceted benefit. You have all of these different products and services that are being generated just simply through the presence and the functioning of all of these species together. Now, in the case of what's being put into place on the plots, you can see that structurally it would look something similar to what we see here, right? We have either this sort of like an alley cropping arrangement where you see some of the trees are kind of buttressing these lanes of the kind of more annual species. We have the perennial trees that are occupying a lane, and again, it's providing shade and cover as well as windbreak. And then also this arrangement of the annuals, these lanes here, would allow for probably some easier access in harvesting and being able to take these things to market. Now, the design that's actually shown here is really it's a modeling or a version of a design that Jeff Lawton had done previously in some other work that he had done in the region, where you can see this arrangement of, again, climate appropriate species. Here we have date palms, bananas, papayas, and figs. This is something that you would typically see in a semi-arid or arid setting. These are all appropriate species. And again, it's how the arrangement is actually pieced together. And you can see that this is also occupied in the sort of in the intercrop with leguminous trees and ground cover. Now, the leguminous trees and ground cover are important because not only do they actually help to give some degree of stability for soil, but they also do soil building. They fix nitrogen, which is used as a natural fertilizing agent simply by fixing nitrogen from the air. And it also produces organic matter, produces shade, all of these different functions that will ultimately benefit the productive capabilities and the functional capabilities of all of these species. We also see that there are, again, various rows, again, that are occupied by the different species. Same basic theme, but again, just different pieces. Here we can see the pomegranates, figs, apricots happen to be called out here, some kind of stone fruit. Again, in the interspace or in the intercropping with leguminous trees and ground cover. And then in the other example, another row, citrus, guava, it happens to be a palm fruit called out here, and pears and stone fruit. So again, depending on the location and the climatic conditions, in the case of, say, the palm fruit, if you have enough in the way of chill hours, where actually that tree would bear fruit, then it could work. But depending on, again, the climatic conditions, this is what's going to indicate what species would be most appropriate for the setting. Here's another figure showing sort of a cross section of how the rows can be arranged along, in this case, with a swale feature, which is helping to take the water that is caught in that water infiltrating feature, and then allow for the slow infiltration of the water to actually feed the roots of those crops. And you can see in each of these rows that you'll find kind of a small water harvesting feature, which would also work in conjunction with some degree of thorough soil conditioning, which would break up the compaction, which often prevents the efficient use of water. So ultimately, this is going to give us all of the different functionality that was highlighted in the, again, the previous list of learning outcomes that we saw at the end of the last session. We get the minimization of evaporation, we got the maximizing of water retention, and then in turn, this will fuel the growth that is needed for ultimately the outcome that we're seeking. So in the next session, we'll examine some of the challenges that are often going to be experienced when trying to implement a plan such as this. Some of them tied to the technical kind of physical difficulties in actually implementing a plan like this, and then some of it just simply dealing with agencies or organizations or individuals or groups of individuals that may make it a bit tricky in getting an idea like this actually applied on the ground. So please come back.